Hello everyone. For the past couple of weeks, I've been writing the logs interpreter in Rust to learn the language. And right now the interpreter is in a very primitive stage and can only evaluate binary expressions. So today I'm gonna add print statements and variable declarations to the language. And for a reference, I'm gonna follow the first half of this chapter, statements and state. So let's get started. Oops, wrong window. And with that out of the way, this is my editor. Right. So first I'm gonna go to the scanner and introduce a new token to represent print statements. Next I'm gonna add that as a keyword so that the scanner knows that print is not an identifier. Insert and print. Next, I'm going to start working on the parser. So the parsers converts the tokens into AST node, and internally the code is represented as AST nodes. So I think it would be better to first represent the AST nodes so that we get an idea of how to parse the print statement. So we should do something like statement parse. And this is wrong. Do something like statement. And so this is gonna hold the print statements, and I also need a way to represent the expression statements, because in the logs programming language every line of code is a statement. So expression statement and print state. So that's all the ASD nodes we need for now. So now we can move on to the parser, and there is a lot of work that needs to be done here because we had to change everything from parse. Yeah, I think self.expression will move down by a couple of functions, and we need to fill in those two functions with parsing functions for print statements and expression statements. Statement. So inside the statement function, I'm gonna first check if the statement is a print statement, else it's going to be a expression statement. So match print self print statement else So a print statement would normally be the print keyword followed by any kind of expression. So we first parse the expression and then consume the semicolon and finally wrap everything in an AST node and return it back. Expression. The consume function. Does the scanner know about semicolon? Check. Okay. Yeah, it does know about semicolon. Yeah, the scanners can scan semicolons. So if the semicolon is not found after the expression, we can print expect semicolon as the error message. Should return error. Okay. Statement. And that's the parsing function for print statements. Next, I'm going to move on to expression statements. Yeah, print statements and expression statements are very similar from the parser's point of view, so I can just copy paste this function. Change the name to expression statement. So the parser for expression statement is also done. So now I'm going to compile it just to see if everything is correct so far. So Rust compile. Oops, I have a bunch of errors. I think it has to do with not importing a lot of stuff. So how to write use create and now we have only one error. Oops, I made a mistake here. So everything seems to be good so far. I have a bunch of errors in the main file, but I can sort it out at the end. So I think we can just move on to interpreting print statements. Alright, I think I have some more stuff to do in the parser, because expression statement. I think we can come back to this later. So now I'm go to the interpreter, and I think I have to change a lot of code here, because even though this interpreter works, the code here is really bad. I want to maintain the logic of this code, but I want to change the function names, and I also want to change how binary expressions are interpreted. So I think we could first start with I think I'll first start with renaming the functions. Yeah, I don't think I'll no longer need the evaluate function, because we only have statements from now on, so it has to be execute. I can comment this whole thing out and then write. It would also be helpful if I put everything inside a struct, so later on when I'm adding variable declarations and the hash map to store all the values, all the functions will be able to access the values inside the hash map. So I should start by creating an struct interpreter, and for now it will not have anything. Or for now we could just say memory is equal to, it's more like a dummy variable, we're not going to use it now. So we can just say memory string type, and we can mark it as unused. And now we have if we put all the functions inside this interpreter structure, all the functions will be able to access a few shared variables. I should first write a function to create a new interpreter instance. It's a very classic Rust function, I guess. Interpreter. It should go in here. Does it mutate the interpreter object? No. So get rid of self. And next function will be interpret. Did I spell that correctly? Interpret. So this function will I think it will not mutate its own object right now, so I think we can do self, but later on when we add the hash table it has to be able to modify the hash table. So I think at that time we should write and mutate self. It will get a bunch of functions, a bunch of statements. And it will return a result enum so that it can keep track of the errors. Oh, that's like 76 characters long. Statement and statements. No, this is not Python. Self.execute statement. If there are no errors inside the for loop, it can return an OK type, OK variant. It's not a type yet. And what this execute function does is it type matches on the type of the statement and calls the corresponding function. So if the first line of the code is a print statement, it's going to call the interpreter function for printing a statement. The function execute. It doesn't need mutate yet. Print statement. I'm gonna take a water break for a minute. Alright, I'm back. And where did I leave? So I'm on the match statement for a expression. So statement. So now I'm gonna write the interpreter function for a print statement. So to interpret a print statement, the interpreter has to first evaluate the expression associated with it and then print the result. It's as simple as that. So print, and it does not mutate itself. Print statement and result. I have to put an asterisk here because the returned value, no, because the parser stores the expression as a boxed value in the heap, and to dereference it I have to use the asterisk. Print ln and stringify. And that's the print statement interpretation function. Next I have to write the expression function. So function expression, and does it mutate itself? No. Statement, expression statement. Yeah, I think the interpreter does not use the value returned by evaluating an expression statement. So I add an underscore to let the compiler know that I'm not going to use the value. So evaluate. So now I'm going to write the evaluate function. So evaluate function is the main function for handling all expressions, just like how we have execute for all statements. Will be value or logs error. just a number, I could just return a OK number. Expression. I could just say OK and wrap it in a value enum. And if it's a string, I could do something similar. String expression. And I have 3 more types of expressions. Could write expression binary. And that's all the expressions for now. Now I have to change a bunch of function names. So this is going to be binary, and it should borrow self and fix the indentation. And this is just a error message to print when the operand of an unary expression is not of type integer. So say if someone says minus hello, we have to let the user know that, and the operand of a unary expression can only be of type int. Operand not a number. No, this is bad. and we should tell unknown unary operation. Yep, so that's the unary expression interpretation function, and we don't need this. And binary. This is also not gonna borrow mutate self, only self. So right now we evaluate the left part of the binary expression and the right part of the expression and match on left right to decide what kind of operation it could be. So if the left and right are both numbers, it could either be plus, minus, slash, star. And but this is not enough because the left and right could also be of type boolean, and it can also be of type string. So I think I'll fix that too right now. So first I need to get rid of everything. Left, right. Token type plus value number L plus R slash number L by R. Greater is a Boolean operation, so greater equal less equal else it's an unknown operation. And next we should write the operations for when the left and right expressions are of type bool. So, value bool type. So when the left and right expressions are of type bool, it could either be not equal or equal. So equal bool is equal to or token type by equal value bool not equal to r, else it's an unknown operation. Copy paste. Next, strike functions for when the expressions are of both type string. And once again, the operation can either be equal or not equal. So token type equal. Okay, I could also add an operation for string concatenation, but I'll add it some other time. W save. And finally, we have to check for types when the left and right operands are of different type. In that case, we'll have two operations. It could be token type equal, and since they're both of different types, it will always be false. And token type value equal will always be true. And if the operation is something else for operands of two different types, then we could say message is equal to operands should be of same type, and throw an error. Message to string. And that's all the functions for interpreter. You could delete these. If I try to compile it now, I'll get a bunch of errors. First I have to import statements. I have to add self before every function call because now everything is inside one struct. I think now I can work on the main function. So there is not much of work to do in the main file. I only have to propagate all errors back to the main function by adding a question mark. So I should do something like scan tokens. Should do something like box error, and now I can propagate the error back to the main function or any function that's calling run and get rid of this. And also I don't need the ungap anymore. And AST node is equal to, it's no longer a node, it's a bunch of AST nodes, so I'll just make it AST. I can also add a question mark here. And I can write interpreter dot interpreter AST And if we have crossed all these function calls, we can write okay. And here I'm gonna declare an interpreter. And inside the loop we first get the input, and if the input is equivalent to exit, instead of breaking out of the loop I should write std process that exit and set the correct shell code. And if it's not match, we run the input with interpreter. I don't know why I keep forgetting the spelling of interpreter. Match, and okay. If there are no errors, we continue with the loop, and if there is some error, I have to print it out. I think instead of doing print new line, I could do something like eprint rust. Yeah, I think I could write eprint line. So and some error to string. I need to add interpreter here. I think I forgot to add a question mark at the end. Interpret. That should work. And that's a success. So I think I can actually run the program now. Exit this and cargo run. If I run now and try print hello world, wow, that works. And if I try 1 + 1, wow, that works too. And if I try some expression statements like this, 1 plus 1, that wouldn't print anything because we're not explicitly asking the compiler to print something for us. So we could write print 1 greater than 0. That's a true. Print 1 equivalent to 1. It's a false. So I think everything works as expected for the print statement. So next I could go ahead and add variable declarations. To do that, first I need to so we have a parser here, and right statement push. So instead of calling statement here, we have to first check if it's a variable declaration first and then go to statement. So I'm going to go ahead and function declaration and self result. So this would first check if it's a variable declaration. So match type var, and if it's of type var, we could call self var declaration. Else call self statement. So for a variable declaration, first we have to parse the variable name. So if the user writes where a is equal to 10, I have to first parse a, then the equal to symbol, and then the value. Consume the variable name by writing self.consume token type identifier expect variable name. So once we have consumed the variable name, I'm going to check if. So there is two kinds of variable declarations. First, it could be where a is equal to 10. So it's declaration combined with initialization. But the other kind is when the variable is declared without any initialization, like where a is equal to 15. So that's what this if condition handles. So So self dot type match like and type equal and we parse the expression self dot expression and then consume the semicolon token types colon. And if we have all the values, we can wrap everything in a OK variant and write statement where statement name and if there is no initialization value, we'll just parse the name and consume the semicolon and wrap everything in an OK variant. Self consume token types semicolon. Now that I think about it, I should also add the AST node for variable declarations. For some reason I completely forgot about it. So go and add statement. Expression statement, print statement, and next we have variable statement and it will contain the name of the variable and the initialization value, which can either be none or it can have a value, so we can wrap it in an option type. Option that's the variable declaration parsing functions. Next I could add the interpreter function for that. And now we come to the heart of the variable declaration statement, which is the environment, which is again built on top of a hash table. So, and for the environment I could create a new file saying right now there won't be much functions inside the environment class or the environment struct, but later on as the interpreter grows, and it has closures and lexical scoping. The environment will become much more complex, but right now it's gonna be a small hash map and a couple of functions to store variables in the hash map and fetch variables from the hash map. And I'll mostly use the inbuilt functions for that and use a wrapper function around it to bring it into the interpreter. So environment.rs and use create interpreter, use collections hash map. String environment. And now I'm gonna write a wrapper function to define variables inside the hash map. And new self name string, and value is gonna be option. So I think here it should be values. So values.insert name value. Name string, and this is going to return an option of an option type. So that's all the functions for the environment file. Next I can go back to the interpreter and use create environment. I should also add this to main. So now we could say memory is of type environment, and a new function is environment.new. And execute will get a new arm for variable declaration statements. Print expression. And now this mutates self. Declaration is a type variable statement. and the result is error. And if there is initialization value, we first evaluate it. Evaluate and then define it in the memory. Define and some value. And return OK. Else, if there is no initialization value, we just define the name and none. Define I'm going to compile it now to see if there are any errors. Just compile. Hash map. Last statement. Last statement. Oh, I think I forgot to add variable type in the scanner. So I should let this scanner know there is something going to be called as variable. Print where GI. src. Types differ in mutability. Should go and add mutability everywhere. Okay. I think there are no more errors, but I'm not sure if I'm calling all the functions correctly. So let me go and check once again. So if I run this now, I'll go down where a is equal to 10. Okay, so that doesn't work, so I think there is some mistake in my code. Number expression is not used. Look at it right wrong. Yeah, I think I have not implemented the scanner correctly. Oh yeah, should add here hash map answer where as a keyword. Declaration, and I think that'll fix it. Fetch is not used yet, so yeah, I think now it should work correctly. So now we can write where a is equal to 10, and it'll execute the statement correctly, but since we don't have a way to fetch the value from the hash map, we can't test it. Could try print a, but it will give some random error message. So variable declaration works now. Let's go and implement a way to fetch variables from the hash map. And for that to work, I think yeah, for that to work I need to add another expression type called variable, I guess. So variable expression, and I could write variable and let me close the window above. indexing. And I don't think I have to change anything in the parser because declaration. But yeah, I think I have to add another primary expression, like else if self.type match. Variable the previous token, and that should work. I think I'm getting some weird error. Okay, this is an interpreter. Okay, that makes sense. So when the interpreter finds a variable expression, it should write expression variable. Right. Function variable. The expression and result value logs error. And I'm going to call a function called lookup. lookup will call the fetch function from the environment and self name token result value. And if the memory returns a none, it means there is no such variable. So we should throw an error saying variable not declared or something. Yeah, I think I could say undeclared variable. And if there is some variable, it could still be either be an uninitialized variable. So we have to once again do a match variable, and we should check if there is some value inside it. If there is value, we could just return the value, and if there is no value, we should say error, lost error, new, and say uninitialized variable. Not sure if the spelling is correct for initialized. And do string. And that should be it. Expression. The expression. String from expected enum value but found a reference to value. And how do I fix that? Batch variable, and if there is some variable type, and match variable, some value, okay, value clone. Yeah, I think I should add I should add the clone. I should derive clone for the statement. If not for this, and yeah, I think I should add clone expression. Yeah, I think I should add hashtag derive clone here. And that gives us and that fixes all our compiler errors. So I think I'll take a break for a minute and be back. Alright, I'm back now and I think it's time to test all the code I've written so far. Did write cargo run, and now I can write where a is equal to 10, and then write print a, and it will print the value of the variable. And what else could I do? You can also write where b is equal to a into 100. Ooh, that's an unknown operation. Why? I think. Oh, that's strange. Oh, I think we have left out star here. There is no star. Yeah. So I think now that I'll fix that. Okay, now cargo run. Okay, right, where a is equal to 10 and print a, that will print the value of 10 and print the value of a, and where b is equal to a into 10, print b, and we'll print the value of b. So yeah, thank you for watching and happy hacking.